Today, instead of having a graph, we're going to go ahead and practice actually finding the slope of a line from a table. So we'll start out with the table. And what you need to realize is whenever they give us the table, we have to understand what is our x and what is our y. And they usually will identify that, but if they don't, and they set it up in this horizontal form, our x is always our top number in our table, and our y is always the bottom number in the table. And when we went through and we worked with rate in section 1, we worked where we would do that bottom number divided by the top number. And so we were practicing already setting it up that way. So when I go through to do this, what we're going to do is we're going to go ahead and find our rate by going through and doing our change in y. So change means subtraction over our change in x. So if I were to pick two of these samples, and it doesn't matter which two, if I pick these two, our change means to subtract. So one method is I could go through and subtract as long as I'm comfortable with integers, and I can work from left to right. So when I look at this, I would write it out this way. My y's are going to be on the top, so I have 0 minus 10. And my x's have to be on the bottom according to this. And the reason that is because really our y's, when we graph them on a graph, are our rise, and our x's are our run. So then for my x's here, I had 0 minus 2. So when I go through and I do the subtraction, 0 minus 10 would give me negative 10. And 0 minus 2 would give me negative 2. What's going to end up happening here is we end up with a positive 10 over 2, which can then be reduced to positive 5. Or 5 over 1, however you would prefer to do that. I do have some kids that'll say, could I reverse the way that I subtracted those? So instead of writing it out as 0 minus 10, could I do it backwards and do 10 minus 0 and 2 minus 0? Yes, you can. You just have to make sure that whatever order you choose for one of them, you do them in the same order. So like here, I did the 10 first, and then I went to the 0 when I wrote it out this way. I have to do the same thing when I do my x's. I can't flip-flop. The reason being is that's going to change whether your slope is positive or negative if you flip them around. So here you would notice once again, 10 minus 0 is 10, 2 minus 0 would be 2. This would reduce to 5 over 1, which would be the same as just a 5 slope. And if you leave it as 5 over 1, that's fine. I do want to point out also, if I had picked two other numbers, maybe I worked with these two. Same thing, if I set it up as a subtraction. If I prefer positive numbers, it's not that I can always avoid working with a negative, but like when I look at this, I say, it'd be easier for me to do 4 minus 2. So I could go backwards and do 4 minus 2, but remember that's going to be my bottom number, and here I am writing it as my top number. And then I just have to remember that I do my 20 first and then my 10, so 20 minus 10. When I do this, I still get 10 over 2, which is the same as 5 over 1. And when you do these, you should always get the same slope. So you can pick any 2 points. I would recommend picking 2 points that are next to each other. It'll possibly help in terms of having you to have to reduce it. But as you could tell from the first one, we still had to reduce. So it's not always going to avoid you having to reduce the number down. Okay, so let's try another one. Okay, so when I look at this, I have my distance on a map X and the actual distance. So this is working with some ratios and a map. So we need to do our change in Y and our change in X. So our change in Y is our difference, and our change in X is our difference. So I'm going to go ahead and put my Y's on the top. So I'm going to work from right to left. So I'm going to do 50 minus 25 because those were my Y's. My X's, remember, since I worked from the right to the left, I have to do the same thing with my X's. So 20 minus 10. And the reason I'm choosing to do it that way is just so I don't have to work with negative numbers. But once again, you're not always going to avoid those. So 50 minus 25 would give me 25 over 20 minus 10 is going to give me 10. So 25 over 10, I'm going to have to reduce down to get my final answer, which when I reduce that down, I don't want a decimal answer. I just want to reduce this to lowest terms. So 5 would go into each of these, which is going to give me 25 divided by 5 is 5. 10 divided by 5 is 2. My slope would be 5 over 2. If I took on my calculator like we did last week, we would do 25 divided by 10, and that would give us 2.5. But we have to remember that with slope, if it's asking for the slope, we have to leave it as an improper fraction, so we can't use 2.5. I would have to then be comfortable changing that to a mixed number, and then once again changing it into an improper fraction. Whereas here, if I just work through and reduce it by the same number, I don't have to change and do all of those extra steps. All right, let's try another one. So remember, it's a change, which means we're going to subtract. Okay, so gallons and miles. So I'm going to guess this is miles per gallon that we can get. So our change in Y. And yes, we're working with some decimal numbers. And some of you might say, oh, I don't like to work with decimal numbers. We could pick the 2 sets here if we wanted to. It's just we're going to have to be comfortable with reducing because when I go through and I use those, I know because they're not right next to each other that with 100% fact that I'm going to have to reduce them down. So, which is okay. I'm going to go ahead and do subtraction between these. So I'm going to put a minus sign just so I remember I'm subtracting. And I'm going to go ahead and do my right first minus my left. So that's my bottom, 20 minus 10. And the top is going to be 650 minus 325. And the reason I chose those two is just so I didn't have to work with decimals. So if I do 650 minus 325, and of course I could use a calculator if I needed to, it's going to give me 325. Over 20 minus 10 is going to give me 10. Now I'm not going to punch in 325 divided by 10. If I was doing the rate in decimal form, yes, I could do that, but they want to know the slope of the line, so I have to leave it as an improper fraction. So when I look at this, 10 won't go into 325, but 5 would go into each of these. So if I reduce by 5 over 5, 325 divided by 5, I don't know that off the top of my head, but I know there's 20 and 100. So 40 is 200, 60 would be 300, and then 5 more. So 65 over 5 divided by 5 is going to give, 10 divided by 5 is going to give me 2. So that's the slope of my line, okay? Had I used one of my decimals, just to kind of show you what would happen, let's say I just used these two, which would be fine. But here's the thing, a slope of a line should never have a decimal in its answer. So if I had used these two, and I'll use a different color just so that we can see the difference. And I had done 325 minus 162.5 over 10 minus 5. Okay, so now when I go through to do this, the bottom number is going to be 5. The top number, 325 minus 162.5, I think is 162.5. Let me double check it quick. It is. So I get 162.5. I cannot leave a decimal number in a slope, which means I would then have to take everything times 2 to get that decimal out of there so that it could become a times 2 would round that to a 10 and then bump up. That's why I chose to pick the two numbers that I did, so I didn't have to worry about having a decimal in my final answer. Okay, so here, the true final answer should be 65 over 2 for our slope. Okay, and I know, yes, you could reduce it down and say something over 1, and if I did the 162.5 divided by 5, it ends up giving me 32.5 over 1, but once again, I can't leave a decimal in my slope, which means I would have to double that to get that 0.5 out of there, which is going to end up taking us back to the 62 or 65 over 2. Okay, so when you see decimal numbers, you have to, if they give you some where there's whole numbers, work with the whole number sets. Okay, so that's working with the table. So the key thing to remember on the table is it's set up backwards. You have to remember whatever's on the bottom, because that's your y's, that's going to become the top of your fraction. Okay? Okay, so the other